Episode 3, Synthetic Extinct Generations Method, Uncombined Generalized Growth Balance, and Synthetic Extinct Generations Method. This third and final episode describes the second and third methods for evaluating death recordings in censuses and offers recommendations on the preferred approach. As we did in the previous episode, here I will present a basic description of the synthetic extinct generations and the combined generalized growth balance and synthetic extinct generation methods for evaluating coverage of deaths using data from two censuses. At the end of the episode, I will also show how to evaluate coverage and adjust pregnancy-related deaths. To reach our goals, first I will present assumptions, data requirements, and the logic behind the synthetic extinct generations method, and conclude this section with an example and its interpretation, as well as caveats and warnings in its application. In the second part of the episode, I will talk about the advantages of combining the generalized growth balance and the synthetic extinct generations method. I will close this episode with the adjustment of pregnancy-related deaths as well as recommendations. As always, you will find a brief learning assessment and additional resources in the last slides. Before you apply the synthetic extinct generations evaluation method, make sure that the census data you are using complies with these 5 assumptions. Age reporting is reasonably accurate. Reporting of deaths and population does not vary with age, at least over age 5 years. Deaths as reported have the same age pattern as did true deaths during the entire intercensal period. Note that only if mortality is not changing will the estimate reflect actual coverage in the census reference period. There are no changes in coverage of population across time, and the population is close or little affected by migration. The generalized growth balance and the synthetic extinct generations methods have the same data requirements. You should have the following tabulations from two censuses less than 15 years apart. Population by sex and 5-year age groups. Deaths by sex and 5-year age groups. Maternal or pregnancy-related deaths by 5-year age groups from 1 or 2 censuses. Now that you know about the assumptions and data requirements, let's continue with the logic behind the synthetic extinct generations method. This method uses age-specific growth rates to adjust the observed age distribution of deaths to approximate the distribution in a stationary population. A stationary population is a special case of a stable population that has a 0 growth rate, neither growing nor shrinking in size, and is equivalent to a life table population. Remember from the last episode that a stable population has age-specific fertility and mortality rates that remain constant over time. The synthetic extinct generations method is based on the notion that eventually every person present in the population today will die in the future. In a stationary population, the number of persons at a particular age at a point in time must equal the total number of deaths arising from this population from that time until the last survivor has died. In other words, the number of persons at a given age alive today in a population not subject to migration will be equal to the future number of deaths at that given age and above of those persons. Therefore, the observed distribution of deaths at a given age and over can be adjusted by current population growth rates at that age and above to equal the future deaths in the cohort. The population at a given age X can be estimated from the period deaths at all ages Y above that age X by applying exponentiated sum age-specific growth rates from age X to age Y to allow for the demographic history of the population. The ratio of the population age X estimated in this way from deaths to the number of entries or birthdays at age X from the census population counts, or BX, estimates the completeness of death recording assumed constant at all ages relative to census coverage, where CX is the estimated coverage of deaths at a given age X relative to population coverage. Please identify the blue markers, which show age-specific completeness, and the red line, which shows the average completeness relative to census coverage estimated using the synthetic extinct generations method. Since the completeness is assumed constant at all ages, the blue points should align horizontally to the average rate of date completeness. Ideally, the blue markers should align on the red horizontal line. In this case, the average rate of completeness is 57%. However, the assumptions have not been met. Age-specific estimates of the completeness of death reporting are not uniform by age or aligned to the horizontal line. Differential coverage of the two censuses can make the synthetic extinct generations method estimates incorrect. In this case, the plot of estimated completeness CX will not be constant but have an upward or downward tendency. To correct that, you can try different adjustments for one census relative to the other until the age-specific completeness line is relatively flat. We call the inclusion of this iterative process the extended synthetic extinct generations method. However, the preferred method is the combined generalized growth balance synthetic extinct generations method, which we cover in the next slides. The combined generalized growth balance and synthetic extinct generation method uses the information on relative completeness of the two censuses from the generalized growth balance method to adjust one of the censuses and get revised growth rates for the synthetic extinct generations method. The combined generalized growth balance and synthetic extinct generation method follows these three steps. First, estimate change in census coverage using the generalized growth balance method. Second, adjust the census data for the estimated coverage change. Third, apply the synthetic extinct generation method and obtain the average completeness or adjustment factor of death coverage, C. The combined generalized growth balance and synthetic extinct generations method is already integrated in the workbook. We provide this information to facilitate its use and interpretation of results. Here I show an application of the combined generalized growth balance and synthetic extinct generations method to census data from Vietnam collected in 1999 and 2009. The adjustment factor of death coverage using this method is 58%, which is depicted in the horizontal purple line. Once we have the estimated average adjustment factor of death coverage, or average C, we are ready to adjust age-specific death rates and adjust pregnancy-related deaths. We calculate the adjusted age-specific death rates by dividing the observed intercensal age-specific death rate by the estimated average adjustment factor of death coverage, C. We adjust pregnancy-related deaths by multiplying the observed number of pregnancy-related deaths by the inverse of the estimated average adjustment factor of death coverage, C. It is important to highlight that the application of adjustment factors assumes that the underreported rate of death reporting for women in reproductive ages, and for pregnancy-related and maternal deaths is the same. To estimate pregnancy-related and maternal mortality measures, we apply the adjustment factors to population and death data, and then apply the proportion of either pregnancy-related or maternal deaths to estimate the measures. From Module 1, we know that pregnancy-related deaths are a subset of deaths of women in reproductive age. We evaluate the proportion of pregnancy-related and maternal mortality via triangulation by checking for regularities in our data and whether our results are close to estimations from other sources. After evaluating and adjusting for census coverage of both population and death recordings, you should assess the proportion of pregnancy-related or maternal deaths in relation to all deaths of women in reproductive age. You can do this by checking the respective demographic and health survey reports of your country for the closest survey year to the second census or the intercensal reference date. You can also use data from the World Health Organization publication on trends in maternal mortality. From Module 1, we also know that maternal deaths are a subset of pregnancy-related deaths. Generally, you should consider the following. Make sure comparisons are consistent. For example, you must not compare maternal mortality with pregnancy-related mortality. The proportion of pregnancy-related deaths is always higher than the proportion of maternal deaths, and these differences should be substantial. In contrast with the BRAS growth balance method covered in Episode 1, the generalized growth balance and the synthetic extinct generations methods do not rely on the assumption that the population is demographically stable. These methods use observed growth rates between two censuses. In sum, if you have data from two consecutive censuses, you should use both the generalized growth balance and the synthetic extinct generation methods. Combining these two methods is considered the most robust approach. The generalized growth balance method is sensitive to the exaggeration of age reported at death relative to the recorded at census, while the synthetic extinct generations methods is more sensitive to age misreporting than the generalized growth balance method. In countries where net migration is substantial, using estimations for both methods for ages 35 and over, when the probability of migration declines, is recommended. The selection of the evaluation and adjustment method for death recordings depends on the availability of census data. Remember that the generalized growth balance method is based on the population balancing equation and generates a true death rate that is contrasted with observed data. The synthetic extinct generations method, on the other hand, is based on the idea that all the population in a cohort eventually dies. Therefore, current distribution of deaths at a given age and over can be adjusted by current population growth rates at a given age and over to equal future cohort deaths. In general, if two censuses are available, the combined generalized growth balance synthetic extinct generations method is the best choice. Please answer true or false to the following two statements. First statement: the synthetic extinct generations method is based on the assumption that at some point in the future, all members of a population die. Second statement: the advantage of the synthetic extinct generations method is that it is easier to interpret because results should line up in a straight horizontal line around the value of the adjustment factor. Here are the answers for the previous questions. First statement: the synthetic extinct generations method is based on the assumption that at some point in the future, all members of a population die. The statement is true. This is the main idea behind the logic for the method. Second statement: the advantage of the synthetic extinct generations method is that it is easier to interpret because results should line up in a straight horizontal line around the value of the adjustment factors. This second statement is also true. While the generalized growth balance, we need to interpret the alignment to an orthogonal linear regression. In the synthetic extinct generations method, we assess how close points align to the average depicted by a straight horizontal line.